Hello again. In this tutorial, I'm going to be modeling the Tesla cavity from start to finish. In my previous video, I think I just modeled for one cell, and when you extend that to the 9 cells without taking into account some things, you do not have exactly the same frequency as the Tesla cavity frequency. So, the classic Tesla cavity frequency, which is 1300 megahertz. So in this video, I'll be going through the modeling, and I think I will have time to do a simulation. Maybe it makes the video long, but then I would do it anyways. So if you should open your CST, you should have something like this, and then if you should go to new and recent, then let's go to 3D simulation because I want to do eigen mode simulation. You select high frequency, and I'll just change it to the eigenmode solver. No, not frequency domain solver, eigenmode solver. Okay, now first things first, your CST comes with a macro to do the cavity modeling, so you don't have to bother about the ellipses and every other thing because it's quite a tricky geometry. So the way you access this is you go to macros, you go to construct, and you go to parts, and then superconducting cavity. Now these dimensions here are the classic Tesla cavity dimensions. That's what you have here, but the classic Tesla cavity dimensions only for the mid cell. Now mind you, the Tesla cavity is not symmetric. It has different end cells, and this was done to dampen the due to high order mode reasons. So if you should look at the description of the cavity from this paper, I think I already showed this in one of my videos, but I'll show it here again, the superconducting Tesla cavity. Then what you have is you have dimensions. Oh, that's too much. That's too much. Anytime now. Anytime now. Yes. You have the diameter, the dimensions for the mid cup, the end cup 1, which would be on the left or on the right, and the end cup 2. So you have different dimensions for these. So if you should model this without taking into account this, then you would not have exactly the same frequency. Secondly, the dimensions on this table are approximate. So if you should use this, you would not have exactly the same frequency. If you should look at the length, for example, it's 57.692, but then in the paper it was approximated to 57.7. Now I could just click OK, and then it creates the half of the mid cell with those dimensions, but I don't want to do that. I want to parameterize it, so I would go to, so I can optimize it later. So I would I think I can press Ctrl Z. Yes, and then go back to macros, construct, parts, superconducting cavity, and then I would parameterize this. So you can use any parameter names, but these are the ones I use and I'm more comfortable with. So R1, I call it the iris radius, which is Ri, makes sense. X length, I just call it L, which is the length, and then R2 is the equator radius, I call it Req. Rx1, I think that should be B. Is that A or B? That's A. I call it AI, and I call this BI. So and then I call this big AEQ, and then I call this, so that's the B at the equator, the A at the equator, and the B at the equator. Now when I click OK, I'm required to enter the unable to evaluate RI. Oh, they're supposed to ask me, but I think I expected too much. So I'll define the parameters first. So AI, I think that should be for the mid cell. Now remember, I would need to define it for the mid cell, so I'll subscript it by M. I usually do this here by M, I think that should be 12. I'll check to confirm BI. I think I have these dimensions burned into my head. 19. Let's see how well I do. Then I have AEQ. No, AEQM as 42. Yes. And I have BEQM. No, 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 no. I think I typed a comma. BEQM, not BEM, BEQM as 42 also. And then I have RIM as 35, and then REQM. REQ is the same for all of them as 103.3. Now this is an approximation. I would optimize it to get closer to the actual dimension. So this is 103.3 was an approximation. And then finally LM. So LM is calculated as the wavelength divided by 4. So I'll do that quickly just to get the exact value. Calculator, I think. Yep, it has a calculator. So the frequency is 1300 megahertz. The wavelength would be 2. Oh boy, do I remember this? 299792458. I think this should be the speed of light. Let's see if I got it correctly. Divided by the frequency. Is it divided by or multiplied by meters per second? Yeah, divided by. So 1.3 E6 gigahertz. Let's calculate that, and then I have this, then I have to divide it by 4, so lambda over 4. Yes, exactly, 57.65239. I mean, production, you do not have such accuracy in dimensions, so I would leave it as, but then simulation we want something exact, so I'll take it to 4 decimal places, or I could just type this whole expression here. Yes, now I have it exact. Now for the, now here's where I'm going to fill AIEQ. I think this should be, no, I think I missed something. I think it should be 9 and 12, then 10 and, okay, yeah, I've forgotten. I don't have it burned in my memory. Let's see. I'm going to open it on another window, so I'm going to move this to a different window so I don't have to keep going back and forth. Oh yeah, I got it. 12 and 19. Cool. The other one that was 10 and 13.5. Oh, it disappeared again. Okay, well, let's see. So this is 10 BI. Oh, sorry, this is AIL. So that's for the left 10, and then BIL, that's 13.5. Then AEQL, I think this should be 40. 40.3 almost. 40.3, and BQL should be 40.32. What else? RIL, that should be 39. That's 39. Yep, got it. And LELL, 56. Yes, 56. And 56. And what else? I think that's it. REQ is the same. So just type in this, bear with me. AQR should be 40.3, then the other one should be, oh no, I don't know, it's 42 also. Okay, that should be the same as BQR. I could also put it as AQR 42. Then oh, I didn't do AI. Iris R. Iris R should be 9 and 12.8. Yeah, that's where the 9 comes from. And 12.8. And then finally I think we have RIR, that should be 39 also, the same as the left side. And then what's the last one? LR should be 57. No, I didn't get that. Okay, I think we have all the dimensions we need, and we'll just go into modeling. Let's see. Back to macros. Construct parts, superconducting cavity. So this is RIM. No, this is LM, and this is REQM. And then this is AI, BI, AQ, AIM, BIM, AQM, and BQM. RIM, LM, firm, RE, AIM, BIM, and AQM and BQM. Hopefully that I didn't mess anything up. Oh, come on, REQM. Oh, okay. Now I have to do it all over again. So I have just REQ, not REQM. I've made the same mistake again, haven't I? Nope, I got you. Yes, so that's the half cell of the Tesla cavity, or at least one of the half cells. Now I like working with my longitudinal axis aligned with the Z direction, so I'm going to rotate this. I'm going to rotate this by 90 degrees, so I go to components, I select my solid, and then I go to modeling, and I transform it, and I rotate. So I'll rotate this by 90 degrees along the Y, preview it, so I have it rotated, and then apply. Now because I like centering my geometry, you could from here keep building forward, but I like centering my geometry. What I'll do is I'll translate this, and I'll translate this by L to the right, so plus LM, preview, and then I have it aligned, and I would apply this. Then the next, I want to mirror it over this plane. So the plane has a normal Z, so I put Z is equal to 1, and then I can preview it. Then because I don't want it mirrored and then keep mirroring, I would have to copy it and apply. Cool, now I'm done with that. Now I just need how many of this, how many more of this I need. So I have 9 cells, and I have 9 cells, that's 18 half cells, and out of those 18 half cells, 16 of them are mid cells. So I need to copy this 8 times. So each of these half cells I need to copy them 8 times. What would be the best way to do this? So I could either copy both of them 7 times, then add 2, or just copy the mid cells and offset them 8 times. Let's see how I can do that efficiently. So I can translate, and I want to translate this. Yeah, still I want to center this, so I would translate this. Just try 2. No, not 2. Should I translate, or should I? Okay, I'm going to translate this by LM, and I need not translate. I should copy, and then I should be able to select repetition factor. That's 2, 3. How many do I need on this side? Maybe 3. I think I may have to recenter it. Let's see. So I'm moving this by 2 times LM. Let's see what that looks like, because I would need this other half to be in this point. So if I have 2 this way, that would be 3. I need 8. So 8 divided by 2, that's 4. But then I have this, so that would be 1, 2. So 1 cell, 2 cell, 3 cell, and then 4 cells on this side. And then going to the other side, it would be another 4 cells. Let's see. So this would be 1, 2, 3, 4, 5, 6. 6 on this side out of 16. So instead of 6 on this side, I need 8. So I would have 1, 2, 3, 4, 5, 6, 7, 8. 8 on this side, 8 on the other side, that's 16. I think this should work. So I am going to apply this. Yes. And then for the second one, I would do exactly the same on one side. Then I'll do the same on the other side. Or I could just do this exactly the same thing, but then on the other side, let's see, translate and copy repetition factor and minus, in this case, 2 times LM. So if I should preview this, then I have this is completed, and the other one is not yet. So I think, yeah, I think I got it. So that's, I mirror this. Yes. And now for this, I just have to do the same thing twice. So for this, I have 2 times LM, and I need to copy it, and I need 4 copies. 4, exactly. Yes, so I apply this, and then in the other direction, so minus 2 times LM, preview 4 times, yep, no, something is, oh, no, 3, I already have one, yeah, 3. Does it look, so I have 1, 2, 3, 1, 2, 3, yeah, correct. So I think that's it. Yes, so I have 1, 2, 3, 4, 5, 6, 7, 8 cells, and then just the end cells to cover. So now I go to my macros because I need a new the end cell geometry. So construct parts and then superconducting cavity. So now I put RIL, L, REQ, no L, AIL, BI, L, AQ, L, and B, EQL. Hopefully I didn't make any mistake. Cross check. Yes. So now I have a new cell. I do exactly the same thing, which is rotate this, transform, yeah, no, not translate, rotate this 90 degrees about Y, preview. So the Y model, this is supposed to be the right, that's to this side. I don't know if you can see my hand movement. So this is Z, and Z is pointing this way, so technically I think this should be the right, but I always use 6 to view my geometry, so in my head this is always the left. So I'm going to call this side the left, and I'm going to move this half cell this way. So if I should move this, now remember I have to, okay, first of all I have to apply the rotation. So apply rotation without copy, and I do not want to intersect anything, apply to all intersections. Okay, now I want to translate this. Now remember I have to translate this the length of these parts, then plus the length of this. So the length of this part is just 1, 2, 3, 4, 5, 6, 7, 8. 8 multiplied by the mid cell length, then plus the left end cell length. So if I should preview this, then I have it exactly. I mean, you could zoom in and see that it exactly matches. So I would move that without copy, and okay, Then now for the final part before the beam pipes, you have the right end cup construct part, superconducting cavity, and you have RIR, LR, REQ, AIR, BIR, AQR, and BQR. Yes, I didn't get any problem. So that's solid 6, and now I rotate it and move it. So transform, rotate. Now I'm going to rotate it minus 90 degrees because I want it to face the other side, to point in the other direction. So minus 90, preview. I hope I put minus 0. Minus 90, I hope I'm correct. Yes, it's pointing in the correct direction, so I apply. Nope, I do not want to intersect. And now I move it by minus 8 times LM plus LR. So if I should preview this, I still shouldn't rotate, so translate. I should have copied that. 8 times LM plus LR. Preview, and yep, you got it here. So that's okay. And now we have all the cells. 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. Voila. One thing I can do, I have too many solids. I could combine all of them. I could just click on Boolean and then it combines everything. Now I'm going to turn off this working plane because it's really annoying. Now when I combine it, I have one solid and I can now extrude the beam pipe. So I select this face. How do I do that? Escape. I press on F on the keyboard and I enter into the face selection mode. You could also click on peaks and then select face or select face chain or pick edge, but I'll just go the shortcut. And if you've selected, to deselect, you just click D on your keyboard and it deselects. So F to select. I select this face and then I select this face and then I go to extrude. So why is it not showing on hover? Is this button here? That's the extrude button. And is this? Yes, that's the extrude. And so I want to extrude face, and the height, you could give it any height, but then I usually use 4 times the mid cell length, but I think 4 is too long, so I'll use 3 times the mid cell length here. And I preview it. I have the extensions, I have the beam pipes, and this is what I have, and I could boolean it again and combine everything into one solid. So this is the Tesla cavity. Now I'm going to set it up for eigenmode simulation. So I have a frequency, just it's in gigahertz. So let's see, 1 point, just 1 gigahertz to 2 gigahertz because I'm going to have 9 modes. No, 2 gigahertz is too much. I think 1.4 or 1.35 gigahertz. Okay, define my background. My background should be PEC, not normal. Okay, and then my boundaries should be PEC also. Apply everything. I'm not going to use waveguide ports. I'm just going to leave it at PEC. At a good enough distance, your PEC is not supposed to, or the boundary condition is not supposed to affect any of your modes, your fundamental modes, because it's localized in the cavity. But for other modes, you'd have to, for propagating modes that propagate out through the beam pipe, then you'd have to be careful. Yes, I think that's that. So I could use some symmetries, but then I want to have the full, I mean, even if I should use symmetries to make it faster, then I should still have all of the TM01 modes, or no? I'll just run it like that. You don't have so much time to think about it. So 9 cells. Would use classy lossless, but I usually just select general lossy. Consider ports. I do not want to refine the tetrahedral mesh, and I want frequencies above 1 gigahertz. So I apply this, save it. Oh, do I have to? I'll just call it Tesla test. And now I can start the simulation. Frequency above 1, I need 9, and start. So I will pause this. I'm just using default mesh settings, so we see exactly the frequency that comes out without any mesh refinement and with the current parameters that we have. So I'm going to pause this because maybe it might take a little time. I don't want to be here when it's doing all of this. So I'll pause it and then be back when it's done. And now it's done. So from the result, you could see from here you have 1.27 gigahertz up to 1.30077. So not good because you have two modes at 1.3 gigahertz, but then it's what we expect. What's the number of tetrahedrons? We have just 25,000 tetrahedrons. No mesh refinement, no anything, and you have that your pi mode is at 1300.78 megahertz, but then your 8 pi over 9 mode, ninth mode is also 1300 gigahertz. Let's look at the mesh. Where is the mesh? Where is the mesh? Where is the mesh? Yes. So it's a really coarse mesh, and yeah, do not expect accurate results. So what I'm going to do now is I'm going to turn on adaptive mesh refinement. I do not want to manually make the settings. So it's going to run until it converges to, and I'll define the frequency variation as 1e to minus 6. So this is the accuracy that I want, and how many passes, just say maybe 8 passes or 10. So this is going to take, I imagine it's going to take quite some time, or 10 passes. Yeah, I think it's going to take quite some time, so I'll pause. So I'll start it, pause. Do I want to keep the mesh? Yeah, I'll keep the mesh. I'll pause and then come back when the adaptive mesh refinement is done and it has calculated. Hopefully it gets to the accuracy of 1e to minus 6 before it gets to 10, otherwise maybe I'll have to cancel it. I don't think I can wait that long. So I could not wait for 10 passes. I think I got up to 8 passes, and what you could see, you could already see the so if you should go to 1-day results, then you could monitor the adaptive mesh refinement results. So you could look at the error. The error is going to, I mean, almost 1e to minus 6. 5e to minus 6 is also okay, but I think this won't have gotten to 1e to minus 6 even with 10 passes. But then what's interesting, what I wanted to show is that if you should look at, why is it like this? Yeah, if you should look at mode 8 and mode 9, mode 9 is converging to, which is your pi mode, 1300.9 something, and mode 8 is also converging to 1300 .1 something, which are both above the actual resonating frequency of the Tesla cavity. So the difference in results was not totally because of the mesh refinement. It was also because of the dimensions which are approximated. So if you should look at the parameters list, what I said that REQ was approximated. I think if I'm correct, the actual REQ is 103.353, if I'm not mistaken. But we are going to do something now. I'm going to assume that the lengths are not approximated, that the lengths are actually exact. So the left end cell length and then the right end cell length, I think it makes sense to assume that these are the exact values. Why is this 56? Oh yeah, it's 56. These are the exact values, and that what was approximated was the equator radius. So with this assumption, I'm going to optimize the equator radius so that I have my pi mode at 1300 megahertz. So I'll go to my optimizer, or I could just maybe try 353. Let me see if I'm correct. Let's see. I'm deleting these results and also the mesh. I think I'll use a coarse mesh to see. Where is it? Where is it? Where is it? Update, yeah. Oh, I think he's using the fine mesh. Oh, come on. Okay, done. Yeah, it's still the coarse mesh. Why does it take so much time? Yeah, still the coarse mesh. So I'm going to run it with 353, which I think should be the accurate result, the accurate equator radius, and just do a quick simulation to see how much better, even with the coarse mesh, the solution is. So let's run that, and I'll pause. Hopefully it pauses this time, and let's see. So I'll pause. So I mistakenly left refinement, adaptive refinement on, and I think I got up to two passes or three passes. Yeah, so you could see that even from the first pass, I don't know if you can, it's really small, but then even from the first pass with a coarse mesh, you could see that the um frequencies make much more sense. Your fundamental mode frequency is already 1.300.0. Remember, from the last result we had, it was still even um, with the refined mesh, it was still 1300.9. So that's about, is it 900 kilohertz? 1.3 1300 megahertz, yeah, about 900 kilohertz 900 kilohertz error from the 1300. But you see that for this, even with the first refinement, it's just about 29 kilohertz error. That's what you have, and you have that the mode 8 is 1.29937. I don't know how different that is um from the fundamental mode frequency. So yeah, that was it. And I think 353 should be the dimension, but then you could try to be exact, precise, and then do an optimization, and you pick your REQ as a goal, and then you could use Trust Region Framework or Eldamid, any of the algorithms that they would. It's a pretty basic optimization. They should give you the answer. So you could select your frequency mode 9, and then you want it to be equal to 1300 1.3 gigahertz, and yeah, maximum difference or maximum or sum of square differences for more, maximum difference score anyone. But then with any of the settings you could get, okay, I'll just add it just to be complete. So I want this to be equal to, I want mode 9, I want this to be 1300 megahertz. I'll do sum of maximum difference, and okay, I think that's that. Then I just start the simulation, but first I need to turn off mesh refinement. Yes, adaptive mesh refinement. No, 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 no. Cancel. So I have the goals, and then I could just start it. And what this does is it optimizes this value to give you exactly 1300 megahertz. Why is my last goal function 1298? It's supposed to be 1300. But anyhow, that's the steps of modeling the full Tesla cavity. And if you have any questions, yeah, let me know. The paper once again is the Tesla cavities. So I can move this and get it without it slipping. the superconducting Tesla cavities. So that's the paper once again. And voila, see you in the next video. Ciao.